Question asks, define marginal utility and how do you derive MRS using marginal utility? Okay, suppose a utility function is given as u equals to, x1, x2, x3, and so on to xn. Okay, all of this. Now, where x1 through xn, the amount of n goods being consumed. Okay, and this is entire thing is your x1 through xn is a consumption, is a vector of consumption bundles. Okay, nth dimensional vector of consumption bundles. Marginal utility of good x1. Okay, this is of say good x1. It is given as your mu x1 is equal to del u by del x1. Okay, it is the extra utility which is obtained from a bit more x1 while holding all other commodities constant. Okay, what is being said is that if you consume x1 a bit more than what you were consuming earlier while keeping all other x's constant, x2 through xn constant, then the change in utility which occurs, that is your marginal utility at x1. I'm again repeating, what is the marginal utility at x1? If you consume more of x1, a slightly more of x1, and then there would be some change in the utility that would occur because of that increase in the consumption of x1. So when you derive that change in x1, keeping all other x's constant, that is from x2 to xn, the consumption of all other x's constant, then that is your marginal utility of x1. Okay, so this is your del u by del x1. Of course, it couldn't be du by dx1 because you are keeping other derivatives constant. You are keeping the utility constant for the other things. So you are partially differentiating this x1, and that is the reason we are keeping del and not d. We're not using du by dx1. Remember this. This is not du by dx1. This is wrong. Okay. So what is right is del u by del x1. Okay. Now, we can write the total differential of x1. If you just see this, how do you write the total differential of x1? Our utility function is this. Okay, this one. So this is del u by del x1 into dx1 plus del u by del x2 into dx2 and so on to del u by del xn into dxn. Okay, but what are these del u by del x1 and del u by del x2 and so on? Mu x1 x1, del u by del x2 is mu x2 into dx2 and so on to mu xn into dxn. Okay, so this is like extra utility that is obtainable from consuming more of x1, more of x2, and so on and so forth. Okay, so that is the sum of the additional utility provided by each of these increments. So mu x1 is the extra utility which you get from consuming more of x1, keeping all other bundles constant. Similarly, mu x2 is the mode of utility which you get from consuming x2, keeping all other held constant, and so on and so forth. So the sum of all these additional increments or these increments, okay, is the extra utility that you derive from consuming these more of x1 and so on to xn, keeping all other things constant one at the same time. Okay, and this is your total differential in the utility. Okay, so this is the change in utility which you get. Okay, now suppose there are only two goods, x1 and x2. Okay, now let's try to keep our life simple, then it will become easier for us. So just assume this, that your utility function, instead of u equals to u, which depends upon x1 through xn, it's an nth dimensional commodity vector. Suppose this is just u equals to which depends upon two goods, x1 and x2. Okay, so your total differential would come out to be MUX1 dx1 plus MUX2 dx2, like this. Okay, so notice that all of the goods are being held constant. See, and you are assuming this. Okay, you're assuming this that you're trying to find out the changes in the level of consumption of x and y when you go on increasing x and y's consumption slightly and keeping the utility constant. Now keeping the utility constant would mean that you are at the same indifference curve, you are at the same utility, so there should not be any change in u. There shouldn't be any change in u, and hence du should be equal to 0. So this entire equation would become like this, that is, it will be MUX dx plus MUY, or sorry, MUX2 dx2. Okay, so like this, it should be dx1. Yeah. So du is only affected by changing the quantity of these two goods, because all of the goods are held constant, and so if you rearrange these terms, what you will be getting is minus of dx2 by dx1 is equal to, sorry, MUX by MUY. Let me just rub it. Okay, this is nothing. MUX by MUY. Okay, remember this, that utility is held constant here. Okay, so, well, this is simply the definition of the MRS. Okay, that is, MRS is equal to the ratio of marginal utility of x1 to the marginal utility of y1. Okay, and this is how you derive MRS using the definition of marginal utility.